right, hello everyone. Head and get into this. Hi. Um, so today we're going to continue kind of working on our transition from Python to Java. We're going to be talking about conditionals, so if statements. We'll be talking about loops and how they're implemented. We will be discussing how arrays are implemented in Java and how they're similar at times and different at other times from Python lists. There's actually quite a few differences. And then we're going to begin our introduction on functions, which will take us into tomorrow. With that, as a reminder, quiz 1 is up. I believe you should be able to see your score in the grade book. If you can't, certainly let me know, but I believe you should be able to see it. You need to get 10 out of 10 to get a perfect score, so definitely strive for that. This is the only quiz you will be allowed to retake, by the way. Other quizzes will be one-shots. You won't get multiple attempts. But with that, are there any questions before we get started today? I'm being asked about cats. There is a Scooby-Doo. Been a bit taking a nap, and Colby Bear is you can't really see, like, behind the chair there. See maybe like a little bit of fur tuft. Morgan Kitty doesn't tend to hang out downstairs. Morgan is my wife's cat originally, and so she doesn't. This quiz also doesn't count, right? I'm gonna probably go ahead and count it just because it will help people's grades. Originally I wasn't going to, but given how short the semester is, I think it might behoove me to make it worth points, because I suspect it will help. Is that guitar a Strat? No, it is a Strat knockoff. It is I bought that when I was in grad school, and I was on a $12,000 a year stipend, so it's not a very good guitar. All right, so with that, let's jump into today, and let's start by talking about how we are going to import Java files. If you'll notice, I have uploaded a bunch of code that you are going to be able to use and reference. These are either examples I'm going to go over in class or similar enough to examples I go over in class. I will always try to upload them before class. That way you can follow along. So let's take, for example, the program Flip a Coin. Now, if you click on this link, it's just going to take you to... I'm pointing like you can see my monitor. It's going to take you to a web page that just shows the file. This is actually a Java file. If you want to download this, you can simply hit on a Windows machine, Control-S, on a Mac, Command-S. S for save. Save the file. It will tell you where do you want to save it. I saved it already to my downloads folder. And now I'm going to show you how to take this file and open it in Eclipse. So the first place is I have it saved into a downloads folder. Make sure there's nothing embarrassing in there. There is not. I have this project I work on. I download a lot of spreadsheets. So that's an esports thing because I have no life. Anyway. So I'm going to take this Flip a Coin file, and all I'm going to do is I'm going to drag and I'm going to drop it into my source folder. Go ahead and say copy files, hit OK, and there it is. I've now opened that file. Let me show that again with a different one. So first, let's say I saved the file array examples, which is one that we'll look at today. Pardon me. From there, this array example, I can just click and drag and drop into my default package or into my source folder. It doesn't matter which. And there we go. The point being, when you're trying to open files, don't double click them. Just drag and drop them into a project in Eclipse. So with that, Let's get started today by looking at flip a coin. And right out of the gate, this is a fairly simple program. This is just designed to illustrate how to use if statements in Java. Certainly, you should be familiar with if statements, given that you were required some program experience in this class. The idea of an if statement's a fork in the road. You either go one way or you go another. So this is a way to generate a pseudo-random number in Java. I say pseudo-random because it turns out that computer programs don't actually generate truly random numbers. The idea of how do you generate a truly random number is actually rather difficult, bordering on impossible, given that computers are finite state autonoma, given that they can't be creative, they're just following instructions. Often random numbers are generated through some mathematical formula. This function generates a number between 0 and 1, and that is inclusive of 0, but exclusive of 1.0. I want to clarify, exclusive means math.random cannot possibly generate 1.0. It could possibly generate 0.0, although it's a very large number of values that math.random can generate, so it's very unlikely you'll ever see 0.0. But this generates a number between 0 and 1. In order to simulate flipping a coin, which is a 50% chance, I am going to say, okay, generate that random number. If it's less than 0.5, the result is heads. Otherwise, the result is tails. And the point of this is to set this string result. So I declare the variable, but I don't initialize it. Instead, I initialize it depending on the result of this if-else statement. And from there, if I run this program, I get should be heads. Head looks a bit weird. Heads, tails, heads, tails, tails, heads. It's random. Are there any questions about this code before we go any further? Because I want to make sure everyone understands the basics of the code before I get into the syntax differences. So the way the if statement works is just like in Python, you have to say if and then some condition. Java syntax necessitates that you surround that condition with brackets. Now, there's an important distinction between Java and Python. In Python, any number that is not 0 is treated as true. Any number that is 0 is treated, or any value that is 0 is treated as false. So you could say something like, if x minus, and this is not Java syntax, this is me just quickly doing some Python. If x minus 5. That would be the same as saying if x is not equal to 5. Because this statement would evaluate to a number. That number would either be 0, false, or non-zero, true. That does not apply in Java. In Java, very explicitly, this condition must evaluate to a Boolean. It must be true or false explicitly. Java does not have any kind of, oh, it's 1, so that probably means true. Doesn't do that. This explicitly must be a Boolean statement. Are there any questions about what I mean by a Boolean statement? Okay. Sorry, I need caffeine today. From there, this condition, if it is true, we execute the if statement. If it is false, we execute the else statement. Now, the else statement is optional, and I can actually rewrite this code such that I do not need an else statement. And here's how I would do that. First, I would initiate result to tails, or initialize it to tails, And then I would only set it to heads 50% of the time. And I've removed the else statement. An else statement is not required. And this code functionally works exactly the same. Heads, tails, etc. Are there any questions why this is the same? Why this works just exactly the same as it did when I had the else? Just to quickly reset. This was where we were at. Oops, I screwed up my redo. Sorry. Gonna have to fix that. So this is where we were at, and this is where we went. Okay. So seeing no questions, there is also an else if. I want to illustrate what that is. Let's say that we also want some astronomically rare chance, but a chance nonetheless, of a coin landing perfectly on its side. So if you've ever seen it's been a trope in movies or sitcoms before, where like, you know, heads or tails, we do this, they flip it, it lands perfectly on its side. How could we simulate that? Well, as I said, getting the number exactly 0.0 is rare. Astronomically rare. It's just as rare to get any other number, so it would be just as rare to get exactly 0.5. So, we could do something like else if r greater than 0.5, we're going to say result equals tails. Else result equals lands on its side. In this case, this would be obviously extremely rare. This would only occur when r is neither less than 0.5 nor greater than 0.5. That is to say, r must exactly equal 0.5. This would be astronomically rare, but a coin landing on its side is also astronomically rare. Are there any questions about why this works? And by the way, if I run this dozens of times, I will almost certainly never see lands on its side. I would bet everything I own on it that I wouldn't see it if I ran it 100 times. Just because, just to show you real quick what math.random looks like. This is the kind of number you tend to get. Just a lot of decimal places. Is math.random always a double? Yes. Math.random is always a double, and that's because it generates a number between 0 and 1. Ints can't be between 0 and 1. You can, however, make it an int. So let's say I wanted to write another program called roll a die. With roll a die, public static void main string args. First, I could get double r equals math.random. I could then say r. So let's think about this. If I want to go from a number, let's just use the whiteboard here. Oh, my whiteboard. Where'd my whiteboard? Oh, there it is. Except it was where I left it, not where I. Anyway, think about this. I want to go from 0. That's the range I want to start from. I want to start from this. I want to turn it into a discrete range. This is a continuous range. I want discrete range numbers 1, 2, 5, and 6. We're assuming a DC. So if I want to convert one of these, well, let's think about this. Width of this is 1. The width of this, there's a possibility of 6. So I could take this number and multiply. Technically, I should know it doesn't. 999. If I take this number and multiply by 6, this is going to give me from 0, 5.999. 5.999. Lots of numbers. Just because I multiply this number by 6. From there, if I convert this to an int by just do a typecast, this is going to give me the number 0, 2, 5. Because 5.999 cast 5. And it will potentially give me every number in between. So how do I get from here to here? Simply add 1. You want to roll a die using a random number generator? This is the basic process you would use. So let's go ahead and let's write that. Oops, wrong. Go ahead and write that. So again, I'm going to take R and multiply it by 6. R times equals 6. I'm then going to say int, let's just call this X for now, equals int R. I'm then going to say X plus equals 1. System.out.println. I typed this. Hang on. System.out.println X. And if I did this correctly, I get 3, 2, 3, 4. I'll get a 6 at some point. There's a 5, there's a 1, there's a 6. Okay. So just to quickly again illustrate, we take the number 0.0 to 1 or to 0.99999, multiply by 6, which is the number of discrete values I want. We then cast that to an integer, which gives me the values 0 through 5, and then I just add 1, which turns that into 1 through 6. So again, going back to the code, I could do this, by the way, all in one line. I could simply say int x equals int r times 6 plus 1. And I should note that the int follows order of operations. It has a higher order of precedent than any mathematical operation, so I have to do the parentheses around r times 6, because I have to multiply r by 6 before I cast it to an int. That's how you get, and if you want to generate a number 1 to 100, you can just change that to 100, something like that. Pardon me. Any questions? All right. From there, will I cast it to an int after time 6? Because if I cast it to an int before I multiply by 6, remember, r is a value between 0 and 1. If I cast r to an int before multiplying, r would just be 0 at that point. Or the integer would just be 0. Because any number between 0 and 1 cast to an int rounds down. So it would just be 0 times 6, which is 0. That's why. Just to I can illustrate this. All I would do is if I just move this parenthesis, then my number is literally always going to be 1. No matter how many times I run this program, I'm going to get 1. And it's because this is always 0. But if I move that parenthesis, it's now anything between 0 and 5.999999 rather than 0 and 0.99999. All right. So I should note that we use else if. There's no elif keyword like there is in Python. Quick question. Does this work? Does the change I just made on line 11, does this still work? And if it does not work, why doesn't it work? Does Java follow order of operations? Yes. Although remember, Java doesn't naturally have an exponent. You have to use math.pow. But parentheses before multiplication and division, and before addition and subtraction, left to right. Correct. It doesn't work because the else is only tied. This, remember, Java does not care about indentation or white space. You don't indent and add white space to your code so it compiles. You do it because it's about making your code easy to read. This code is a lot easier to read than this code. But functionally, they are identical. The code works exactly the same. I haven't changed how the code works by removing the white space. I know that's not true in Python, but that is true in most languages. So the reason we add white space is to improve human readability. As a result of this, the else is only tied to the last if statement. Or at least the chain of if statements. So that means that this else is only tied to the second if. Technically, if you think about how this code's written, it's actually written like this. And the consequence of writing it this way is that it will print land on its side even when the value is not exactly 0.5. In fact, this will never print heads, no matter how many times I run it, because if it sets results to heads, that means this statement is false, which will trigger this else. If you want this else to only work when this and this if statement are false, you have to use else if. Else if is how we chain together multiple if statements. Are there any questions about this? Hopefully I'm not showing anything overly new here. All right. So now another, so that's conditionals. The other thing you should be familiar with from before is loops. That is, perform some step a set number of times. And to do that, we're gonna take it to Sesame Street. I wrote a program called the count. And the count asks you, and this is, by the way, a quick way to get user input. It asks you to enter a number, and it will then count to it a la the count from Sesame Street. So if I run this, run the count, how high would you like to count? Let's say 5. This will count 1, 2, 3, etc. The number of the day is 5. So, how does this work? It works using something called a for loop. And a for loop is used to loop a set number of times. And the basis of the for loop is there's 3 components. I'm going to go through the whiteboard to diagram them real quick. So the for loop has 3 components. For, those 3 components are separated by semicolons. Note that there is no after the last one. You'll typically have an open bracket. The first is our initialization. We're going to set some initial condition. Second, our continuation. And we continue to loop while this. The third is our increment. This is what we do but every loop. And so if I wanted to say count from 1 to 10, I would create some counter variable. Very often we like I, int I 0. I would keep looping up to and including when I is 10, I less than. And every step along the way, I would increase I++. As a reminder, x++ is the same, and this is a way of saying equivalent. That is, this is the same as saying, that is add 1. In this case, add. The key is we would enter this, and the I variable, you think of I as a box holding a number, would then perform whatever code is inside the loop from the open bracket to the close bracket. Whatever code is in here, we would execute. We would then say, okay, I++, so I becomes 1. And then we would check, is this condition true? If this condition is true, then we loop again. False. Yeah, sorry, the sound drops out sometimes when I'm far away. Let me turn my noise gate down. I have a noise gate to prevent you from picking up random background noises, but I think it's just a little bit too aggressive. Hopefully that will go better. Did anyone miss any critical thing I said? The reason the sound is going out is just because when I'm farther away, the sound has to travel farther, and so sometimes I'm just a little bit too quiet for it to pick it up. So I apologize. I just turned my noise gate down, so hopefully that won't happen. Also, when I'm looking at the board, you're not going to get as much sound either. Okay. So did anyone miss any of the things? So we have our initialization that creates a variable. We have a condition that when this is no longer true, we exit the loop. And then we have this incremental that we perform every step along the way. By the way, we call this the incremental, but it doesn't actually have to be an increment. It could be a decrement. This could be literally any statement. But what it means is between when you end the loop and before you check the condition, you apply whatever this incremental is. So now, the one thing you'll hear, though, is me jostling around more, because my noise gate is now quite a bit lower. So I apologize for the random pops and clicks you might hear, especially when I use my keyboard. So from there, let's take a look. So here is our initialization. I create a variable called I. Here is my continuation condition. While I is less than n, stay in the loop. Keep looping. And then I++. So the first time through the loop, I will be 1. It will print 1, ah, ah, ah. Then we do I plus plus, I becomes 2. We check, is I still less than n? In this case, I said n was 5, so it is. We re-enter the loop, we print 2, ah, ah, ah. We increment I is still less than n. 3, ah, ah, ah. Increment I is still less than or equal to n. 4, ah, ah, ah. Increment I is now 5. 5 is less than or equal to 5. So 5, ah, ah, ah. And then finally we increment I is now 6. 6 is not less than or equal to n, so we leave the loop. So we just immediately pick up on the next line of code after the loop. We print the number of the day is n, which the number of the day is 5, and then we're done. If the incremental didn't increment, is that the case for an infinite loop? Depends. You can't, like, so if for example I just said I plus equals 0, then yeah, certainly I'm going to get an infinite loop here because I never changes. And so the loop would keep going because I would never actually reach the condition where I was greater than 0 that caused me to exit the loop. I'm going to show an example of an infinite loop in a second. One thing to know about this for loop is that if the condition is initially false, the loop will be skipped entirely. And here's what I mean by that. Let's say I said I want to count to -3. Notice I never count. This print statement never runs. And it's because I is 1, I is never less than or equal to n, so we never enter the loop in the first place. Now, there is a simpler loop, and it might be the one that you were first exposed to, but there's a very good reason that I chose to do the for loop first. Because you talk a bit about n and so n is just initialized here. This is how I get user input. So I print, how high would you like to count? I create a scanner that just reads whatever the user types. This is similar to input from Python, but the key is you can specify the type. This specifically looks for an int. Pardon me? And then from there, I initialize I to 1 because when I start counting from 1. Now you may be thinking, wait, don't we start counting from 0 in computer science? Yes, we do. But if you watch Sesame Street, the count does not start from 0 because the count is a vampire, not a computer scientist. I know that both of us hate the light and generally are antisocial, but there are differences. So vampires start counting from 1, computer scientists from 0. There's a couple other differences, not as many as you would think. Is Java util scanner required for user input? It's the simplest way to use input, and you do have to have this import statement. I will say that I'm not going to throw scanner at you on the exam. I'm not going to expect you to know how to use scanner. But in order to get user input here, I needed to do something. There are other means to get user inputs, like you can write a GUI, for example. Scanner is probably the simplest. And we'll talk about what the heck this is later. This, by the way, relates to object orientation. This and then keyboard dot. We'll talk about that, especially on Thursday. Any questions about the for loop before I go to the while loop? All right. So a while loop, let's write this exact same program, but instead with a while loop. By the way, what I'm doing here, this is a block comment. Sure, I can do one later. I'll do an example with a reduction in a bit. I mean, the only difference is basically I would be a larger number than n, and then I would just do I minus minus. That's all. All right. So, what I could do with a while loop is I could first say int I equals 1 while I is less than or equal to n. Do the same print statement and then do I plus plus. And this works exactly the same way. And you may think, well, this looks a lot simpler than this. This has a lot of syntax to it. I think I'll stick with while loop. It's easier. I want to highlight that the while loop has exactly the same code as the for loop. Exactly the same. Just first to illustrate that this code works, let's run this. How high would you like to count? 5. Exactly the same output. There is no less code here. Notice, what do I need to do before my while loop? I need to initialize a variable. Look at my for loop. Initialization. What do I need to do while, when do I need to stop looping? When I is no longer less than or equal to n. I no longer less than or equal to n. That's when I would exit this loop. What do I need to do at each loop in order to prevent an infinite loop? I need to increment I. I increment I. It's exactly the same code. So a while loop is not simpler than a for loop, and I would encourage you to get into the habit of using for loops when you can, as we're going to talk about looping through arrays here in a second, and most of your array looping, most of your code that loops through an array is going to work exactly the same. Do that. Anyone getting a fuzzy? I think it's your connection, but certainly... so one thing you should note, Twitch, I believe by default has set bandwidth lower than source in a lot of cases. I'm streaming at 720p. I'm not streaming at 1080p just because I do actually have a data cap at home. Yay, Comcast. Now my stream's just gonna get shut off because I talked bad about the internet gods. Anyway, any other questions about the for loop or the while loop as they are written right now? I should note that if I don't have I++, this is what will happen. It is continuously printing one over and over and over and over and over. Forever. Can you put a loop inside a loop? Yes, you can. You absolutely can. So for example, and I'll do an example when I get to arrays. I'll show you how you can make like a deck of cards real quick using a nested loop. So how will we do loops with user inputs without using the scanner? I mean, you can do loops with anything. The user input is not part of the loop. It's separate. But, like, this is how I know how to get user input. I'm not saying other ways don't exist, but, like, I mean, you're kind of asking me, like, the way that question's worded is it's almost like asking, how can I sate my thirst without using liquid? I don't know. I'm sure there's a way to do it, but it seems like it's an unnecessary constraint when you could just use liquid. How to loop through a for... so that one, we need to talk about arrays before we can do that, and we will do that. Can you read a file using the scanner class? Yes, you can. If we get to it, we will. There's a lot of libraries for reading files, I should note. I personally prefer buffered file reader over scanner. Yeah, there's a lot of different libraries. We're not going to get into it today. But, you know, if I have time one class period, I may cover it. Are there any other questions about loops? So let's do just a countdown loop. So I could do something like public static void main string args. And then let's say we want to count down from 10 int, or let's say, well, let's just count down from 10. I don't even need to declare a variable. I can just say something like for int I equals 10, I greater than 0, I minus minus, system.out.println I, and then maybe something like system.out.println blast off. Because you don't say 0, 0, you just say take off or blast off or, whatever. And there you go. I mean, the only thing is, where do I want to start? I want to start at a big number. When do I want to stop? When that big number is no longer a big number. It is instead 0. How do I get there? One step at a time, going downwards. That's all. What is a for each loop? In order to talk about for each loops, we need to talk about collections. So I definitely need to talk about arrays before that. A for each loop is a different way to write a for loop in order to visit every element of a collection. And we'll talk about what I mean by that in a second. But are there any immediate questions? All right. So now, let's take a look at arrays. So the first thing to note about arrays in Java, they are similar to Python lists, but they are critically different in a few ways. I'm going to start a new file, and then I'll just reference the file that I have before. Let's just call this June 16 arrays. I'm very not good at coming up with names on the fly. Public static void main string args. So arrays are a collection of information that is ordered. Ordered does not mean sorted. It just means there's a first element, there's a last element. But in Java, unlike in Python, arrays have to be homogeneous. Homogeneous. Anyone know what this word means? All the same what? So all the values have to be the same value? All the same type. There we go. All the same data type. So, when I declare an array, I can declare an array of a primitive data type exactly the same as I declare an individual data type. The only difference is, instead of int x equals 5, I say something like int a equals new int 5. This is not an integer, this is an integer array. Now you'll notice that I don't specify initial values. Instead, I say this new keyword, new int 5. And I want to take a minute and explain why this is done this way. And necessarily, we're going to have to start talking about a distinction between, let me try to adjust the camera a bit. No, that's not going to work. Okay. Did what I could. Necessarily, we need to start talking about a division between a stack and a heap. Now, up until now, all the primitive data types that we have created are stored on the stack. So if I say, and I'm going to just have some code down here in the bottom left. If I say int x equals 5. Hi, Colby. Colby has decided that he wants attention right now. So I will do the best I can to provide that. Okay, so if I say, well, I tried, and now Stuart knocked my camera over because he's jealous. Okay, we're just going to put the cats away. We tried to let the cats be happy, and they chose not happiness. That creates a variable on the stack, and that contains the number 5. When I say int array A equals new int 5, then this creates a variable called A on the stack, but this does not contain the array. And that may seem strange. This only contains a single value. And it turns out that this value is like X, it's a number that is 32 bits. But what that number is it's a memory address. Is this... Okay. Sorry, I just thought I saw some new messages, but there weren't any. Okay. Instead, the array, which says, and I'm going to pull the code back up here, the array, which says new int 5, specifies not a value, but a size. That is, create an array that holds 5 elements. And so on the heap, I create an array that holds 5 integers. Now, as we talked about before, an integer is 4 bytes. So this array takes up 20 bytes. And there are 5 cells in this array, each of which can hold a different integer. So you can think of this A as not being one variable, but as being 5 variables. And this array is stored at some memory address. I'm going to make up a hexadecimal number off the top of my head. If you're not familiar with hexadecimal, don't worry. What is the difference between stack and heap? We will get there. Until we get the functions, it's kind of hard to distinguish, but I will get to the difference in a second. It gets to the core of object-oriented design. So from there, I have all of these cells have an index number. 0, 1, 2, 3, and 4. 0 starts at a memory address. Every byte in your memory is numbered. Let's make one up. Let's say 4, 7, 3, C, D, E, 6, 4. Let's say that that is the memory address that my array starts at. Completely made up. Don't worry about it. The point is, this is just a placeholder. This would be a 32-bit number. What will be stored in A is not the array. It is instead 47, 3, C, D, E, 6, 4. It is the memory address. So it points to where the array is stored. And this gets to the core of the difference between primitive data types and non-primitive data types. Int x is a primitive data type. Even though A is an array of integers, A is not a primitive data type. A is a reference data type. A is an object. And objects on the stack only store the memory location, not the value. And the heap is where the values are stored. So this creates an array of size 5. And we'll talk about how to actually use arrays in a second, which if you've used Python lists is not going to be surprising. And by the way, Python lists also work this exact same way. That should also be noted. So A holds the address, which directs it to the heap. Correct. So you can think of your array as like an apartment building. This is an apartment building with 5 rooms. Each of the 5 rooms holds a number. A is just a piece of paper where we wrote the address of that apartment building on. A is not the building. It's just a piece of paper with the address on it. That's all it is. Are there any questions about this part so far? We'll talk about the consequences of this later, but I just want to start with this drawing. All right, so let's take a second and let's look at how we can use this array. So I could populate this array. Let's populate it with the University of Virginia's zip code, which I believe is 22901, I think. I'm going to go with that, and if I'm wrong, oh well. I don't actually care. So I'm going to populate it by first saying A0 equals 2, A1 equals 2, A2 equals 9, A3 equals 0, and A4 equals 1. Now you may think, well, why don't we just print A and see if that worked? And this is where some of you might get a bit confused. This is what prints. And that may not look particularly useful. But it turns out that this actually is what the array variable A is. Remember, that variable A is not the array. The variable A is the memory address. It's an 8-digit hexadecimal number. What is this that I just highlighted? Well, that's an 8-digit hexadecimal number. That's a memory address. My computer has a memory address for Java at 15DB9742. And that is where my array is stored. On my computer, which is right there. It's a physical place on my computer that array is stored. If I were good enough, I could physically point to where on my memory chip that is. I'm not that good. So, how can we print the values of A? Is the whole array is stored, not just one apartment of the building? Yes, so the whole array starts at that memory address, and so these memory addresses are sequential. So starting from this memory address, the next 20 bytes all belong to the array. The first 4 bytes are the number at index 0. The next 4 bytes are the number at index 1. The next 4 bytes the number at index 2. The next 4 bytes 3. The next 4 bytes 4. After that, this memory immediately after, so 21 bytes after this, is memory that could be for anything. There's no way to know what that memory is. All I know is from here, starting this byte and the next 19 after it are all part of this array. So how can we print an array if we can't do it this way? Well, there's a couple ways to do it. The first would be to go through the array one element at a time and print each element one at a time. How can we do this? Well, let's give it a shot. Let us try the following. For int I, what is the first address I'm going to start at in the array? If I'm going to loop through my array, what's the first address I will start at? What was the first address you started at if you loop through a list? 0, exactly. So I'm going to loop while I is... Now, I could say I is less than 5, but that's hard-coded. What if my array size isn't 5? You can get the size of an array with the variable name .length. Variable name .length gives me the number of elements in that array. So a.length gives me its 5 elements. A.length will give me 5. From there, I++. Almost everything you ever write to loop through an array will look like this. And then we could just do system.out.println, and how do I get the ith element of the array? How would you do it in Python? It's actually the same in Java. What would I write to get the ith element of the array? AI, exactly. Get the ith index of the array. Oops, semicolon the wrong place there. So let's run it. And there you see I print 22901. There's another way to write this loop that's a little bit shorter. I can also visit every element in order in this way. For, and I'm just going to write it and then I'll explain it. For int x colon a system.out.println x. Oh, I already have a variable called x. I can't call it x. S. Is it possible to write that loop as a while loop? Yes, and you're welcome to do it. I'm not going to do it. I think it's a fairly trivial application of what I did earlier. I would encourage you to do a for loop because I think it's a better habit to develop. But this is another way to do exactly the same thing. What this does is this visits every element. It visits A0, and then it visits A1, then A2, then A3, then A4. It visits them, and it takes whatever value is stored there, such as the value 2, and it stores that into the variable s, and then runs this. So the first time through the loop, s will be 2. The second time, s will be 2. Then s will be 9, then 0, then 1. The downside of this approach, while this is definitely fairly smooth, fairly straightforward, the downside of this is there's no reliable way to go from S to the index S is stored at. S gives you the value. It does not give you the index. And so, for example, if I need the index, I would always need to do a loop like the first one. An example of when you would necessarily need the index is if you're doing something like sorting. But if you don't need the index, if you just need to visit the value, let's say I want to just print every value. Or maybe I want to get the sum of all of these numbers. I could do a loop like this. For example, let's do a loop that gets the sum of every element in this array. Get the sum of every element in the array A. I could do that by simply doing, well, I could start by writing my loop. And let's do for int t in A. System.out. No, I'm not going to do system.out.println t. I'm going to get the value t, and I need to somehow get a sum. In order... Colby, shh, Dad's teaching. Sorry, you guys probably heard that meow. It was very loud. From there, I'm going to create int sum. And this is going to be my accumulator variable. And this is a very common strategy. I'm going to visit every element and accumulate some amount of information. From there, I will do sum plus equals t system.out.println sum. Now, before I run this code, I want to make sure my code is working. So what I'm going to do is I'm going to think, okay, the sum of this, 2 plus 2 is 4, plus 9 is 13, plus 0 is 13, plus 1 is 14. So I'm going to make a note. This should print 14. And what I'm doing here is I'm designing a test. I am testing my code by making sure it works the way I think it does. And that's always a very important step. Let's run this. And you can see here I print 14, which is what I wanted to print. So this is how you can do some accumulation. And you can apply this to, say, finding the max, or finding the min, or getting the average, or, doing something like counting the number of times the number 2 appears. All of this would be done by defining an accumulator, performing some loop that modifies that accumulator, and then returning it or printing it. Does this method work for strings? No. Well, hang on. I don't know what you mean by does this method work for strings. Can you print the zip code on one line? Yes, I can do that. Here is how I can print the zip code on one line. Instead of print, I just say print line. The downside of this is now you'll notice 14 is on the same line. I can solve that by, after this, doing system.out.println, which will print a new line character. And there you go. I'm not sure what you mean by does this method work for strings. I'm not sure. If you could clarify that question, I'll try to answer it better. For the for loop structure, is the first value before the colon always an int? No. The first value is whatever is stored in the array. So, for example, here I have an array of Jenny, who can I turn to? This is an array of strings. If I wanted to loop through this array, I would need to do for string s in words, and that's because the words array is data type string. So you can create an array of strings, of ints, of doubles, anything. Can you get the values using for loop? Sure. Yes, I do that right here. Sorry, I did misunderstand the question. Yes, so you can have an array of non-primitive data types. You can also have an array of arrays, and that is actually how two-dimensional arrays are implemented, if you want something like a grid. So whatever data type the array is, that's the data type you store. By the way, this is shorthand to create an array on the fly. So for example, rather than building the array one value at a time, when I initialize the array, and only when I initialize the array, I'm allowed to do the following. 22901. And notice I'm using the curly brackets here. And this is just going to create the array to look like 2, 2, 9, 0, and 1. There's another way, by the way, that's even easier to print the array. However, I wanted to justify why we're talking about loops, because anytime you use an array, you're almost certainly going to use a loop. But, to that end, you can do system.out.println, and then it is capital A arrays dot to string, and then in parentheses, the array that you want to print. Not deep toString, sorry. It should just be toString. Autocomplete sometimes does things I don't like. This prints the array. Oh, hang on. Oh, sorry. I thought that was a comment. So if you want to print an array to check it, you can always do arrays.toString and then just the array variable. Are there any questions about that? All right, so we're going to take our 5-10 minute break-ish, but while I'm gone, I want you to start, and this is not today's daily activity, but I want you to take a look at, on Colab, this file 1D array activity. This is not today's graded array activity, but I at least want you to just start getting some practice here. What I want you to do, and we'll work on this after the break, is save this file, which I've already saved into my folder. You're then going to drag it into your Eclipse folder. And by the way, you're encouraged to jump into Discord and work with other people on this. And I want you to try to solve this problem I gave you. So I want to illustrate what the nature of this problem is. I'm first going to say how many values I have in an array. Let's say something like 5, 2, 2, 9, 0, 1. And it's going to then print the array. What I want you to do is after this, I want you to insert information here. Very specifically, I want you to write something that will print whether or not the array is an ascending order. Here's what I mean by that. If my array were something like 4, 7, 9, 12, that is ascending. If the array were something like 4, 7, 9, 7, that is not ascending. Similarly, 4, 4, 7 is not ascending. So I want you to try, work with each other on that during this brief intermission we'll take. We'll be back at 2:18 p.m., but I want you to try to work with each other on this in the meantime. Again, feel free to pop into the Discord we have set up and work with each other. This is for in-class activities, and even though this is not today's graded activity, but we will come back to this after the break. But I always encourage collaboration during class. I see no downside. So looks like we only have a few people in the Discord, but go ahead and give this a shot. So we'll take our break. And this is what you want to try to write here. You want to write a loop that determines whether or not the value is ascending. All right, we're going to take our break. We'll be right back. All right, hello everyone. Welcome back. So we are going to go ahead and start looking at a solution to this problem. Keep in mind that this will be my solution. If your solution works, it's fine. I don't need to answer every possible permutation of a correct solution, but I do want to work through how I would solve this problem. And the first thing I want to do is take a minute and actually diagram the solution. Sorry, I have the camera set up on my bookcase. For a second. Oh, gosh. It doesn't seem to ever want to stay standing. It's because the cord kind of gets tangled on it at times. All right. Yes, I will put it on Colab. My camera keeps not wanting to stay standing, and it's frustrating. I do apologize for this. The camera legs are very, very short. There we go. That should be better. Okay. Technically, actually, I probably won't put that file up, and the reason is Array Examples has all the same information. It's just that it's in a much cleaner format. So I probably won't put that file up just because Array Examples.java literally has all the same information. Um, anyway, so let's think a bit about how we want to do this. Let's start with an array. let's say an array of size, for now 6, 4, and let's start with an ascending array. How would we go about proving this array is ascending? 12, 15. How would I go about proving it? Well, what I could do is I could step through this array one step at a time, and I could say, for each cell, is the next cell greater? And if it is, we keep going. If it is not greater than, then I just simply say false. It's not ascending. So how can I do this? Well, first, one tool that may help us. We'll not do it that way yet. We'll just stick with what we have. So I need to loop through this array, and I need to compare 0 to 1, and then 1 to 2, and then 2 to 3, and then 3 to 4, and then 4 to 5. So I need to compare each of these two pairs. So how do I do that? Well, that means I need to compare, for every I need to compare it to I plus 1, right? If I'm comparing 0 to 1, if I is 0, it's I, 0, I plus 1, 1. If I is 3, 3 to 4. So let's start with that idea. I know I'm going to loop through this array. I know I'm going to loop through this array, and I will, by the way, put a solution. I will put this solution up. I will overwrite the old 1D array activity with the one that I'm going to have finished. So for now, let's just start with a for loop, and I'm just going to leave first int I equals 0. I'm going to leave the next part blank for the time being. We will fill it in later, and then I plus plus. And I'm going to say, first, define my accumulator variable. Boolean is ascending. And I'm going to assume that the array is ascending until I find proof that it is not. That is, it is innocent of not being ascending until proven guilty of not being ascending. And then all I need to say is if a... what's my array value called? Oh, values. Okay. If values I is greater than or equal to values I plus 1, then is ascending equals false. This is the basis. If I find a single counterexample, then is ascending is false. Does everyone understand this if statement? Or does anyone have any questions about just this if statement? And how it related to what we drew on the whiteboard? Now from there, I am of course looping from I to 0, and I'm doing I plus plus, but you have to be careful about this middle part, because you may think it's as simple as I less than values.length. But if you did this, you will find that your program crashes. So first, I'm going to loop through this array, and then let's just do system.out.println ascending plus is ascending. So this will print either ascending true or ascending false. Let's give this a shot. Let's say, looking at my whiteboard example, I had 6 values, 4, 7, 8, 10, 12, 15. So 6 values, 4, 7, 8, 10, 12, 15. And my program crashes. My program crashes, and I want to take a minute and look at what happens when a program crashes. Your program, if it fails to compile, that is a syntax error. And you cannot run your code at all. If your code compiles, but something happens that causes the crash, that is called an exception. And I'm going to write that word down here. Exception. And an exception means that something has occurred such that your program cannot continue. And one of the most common exceptions that you will run into while debugging is something index out of bounds related. And this is caused, I can do a quick example of what causes this exception, which is fairly straightforward. System.out.println A6. Notice there are only 5 values in this array, so that's index 0 to 4. There is no index 6, but this code compiles. When I run it, however, it crashes, and it crashes at line 8 with an index out of bounds exception. That means that I tried to access a value that is not in the array. Going back to our 1D example, let's try to debug where this happens and why. So let's try that same example again. I have 6 values, 4, 7, 8, 10, 12, 15. It crashes specifically at line 40. Can anyone tell me why this line of code is crashing? Why am I getting an array index out of bounds exception here? Go ahead and take some time to think about it if you don't know, but if you do know, feel free to type it in chat. Well, there is no value 7. I should note, by the way, going back, there also is no value 5 here. So notice I have 5 values. There is no value 5. Going back to how arrays are constructed, yes, Badger fan has the correct answer. There is no value 6. Going back to how arrays are constructed, they're just like Python lists. Remember, this is 0, 1, 2, 3, 4, and 5. The length is 6, but the valid indexes are not 0 to 6. It's always 0 to 1 minus the length. So the length here is 6. So 0 to 5. These are valid indexes. Anything less than or greater than this range is out of bounds. And specifically, because of how my loop is written... Oh, wrong scene. Sorry about that. I know, no one wants to see me blown up that big. Because of how this is written, this loop will run when I equals 5, which is the last value. So I'm comparing values 5 to value 6 in an array of size 6 where there is no value 6. So I need to stop not at values.length, but at values.length minus 1. I need to stop 1 earlier. And this makes sense because the idea is, going back to the whiteboard, how many comparisons do I need to do here? I don't need to do 6 comparisons. I only need to do 5. I need to do this comparison, 1, this one, 2, 3, 4, and 5. So I do 1 less comparison than my length. So, with that small change, values length minus 1, let's go ahead and try this again. How many values in the array? 6, 4, 7, 8, 10, 12, 15. Ascending is true. Let's run the program again. Let's use one of our inputs that is not ascending. 4, 7, 9, 7. How many values? 4, 4, 7, 9, 7. Ascending is false. So be careful if you're doing comparisons between values that you don't always loop to every value I. Sometimes you stop 1 early, 1 late, depending on what the problem entails. Now, some of you may note let's say my array were something like this. Let's say that my array were, let's say, 100 units long. There's 100 values. And the first two values are 2 and 0. The first two values are 2 and 0. Do I need to check any of the remaining 98 values to know this array is not in ascending order? No, this array, it doesn't matter what the remaining 98 values are. This array is clearly not in ascending order. So how can I prevent myself from wasting time checking if a problem is already solved? Well, to do that, we're going to take just a brief second and go over break and continue, which hopefully you've seen before. But if you haven't, I'm at least just going to briefly show them. So here, let's say that I'm going to be looping for int I equals 1, I less than or equal to 10, I plus plus. And I'm just going to count from 1 to 10. System.out.println I. I'm then going to write before this, if I equals 5, and this is how you check if two numbers are equal. If I equals 5, then from there, I'm going to write break. If you've not seen this before, if you've seen this before, you'll know what will happen. But if not, let's quickly show you. And I'm going to delete the rest of the program here. As I said, there's already an example of this. Array examples shows everything I've shown here. It's just, it's more clean, it's better commented, etc. From there, if I run this program, you'll note that I only print 1, 2, 3, 4. And the reason is break means get out of the loop now. Leave the loop immediately. Don't pass go, don't collect $200. Leave the loop. This means that when I is 5, we never even reach this print statement. And further, I is never 6, I is never 7, etc. We exit the loop immediately. Using that, if is ascending is at any point false, I can just say break. Because once I found that it's not ascending, there's no way it's going to be ascending anymore. It's obviously not ascending if you find one counterexample. So I can leave the loop. I don't need to keep spending any programming time on it. I should note, there is also another one, continue. And continue, notice that it goes 1, 2, 3, 4, 6. There is no value 5. Continue means skip the rest of the loop this time, but still apply the incrementation and check if you need to re-enter the loop. Don't leave the loop entirely, just skip the rest of this iteration of the loop. That's all continue means. So notice we never print 5. Any questions about continue or break? Now, I want to take a second, and actually before we move on, I want to talk about determining if two arrays are equal. Let's say I have two arrays. I have int array A equals 3, 2, 1. And I have int array B, which is new int 3. And I'm going to do B0 equals 3. B1 equals 2. B2 equals 1. What is going to print when I say this? What is going to print? Most of you are saying false. At least 3 of you so far. But some of you might be a bit confused. Why false? Because if I print these 2 arrays, just to clarify, system.out.println A. Seems like most of you know this lesson, but I do want to make sure I hit it just in case people don't. And system.out.println A dot, arrays dot toString A. And arrays dot toString B. If I print these 2 arrays, they're going to look the same. Right? 321, 321. So why is it saying false? For those of you who said false, what would it have to be true for this to print true? Even though these arrays have the same value, why aren't they equal? Well, here's why. Because when I create these 2 arrays, let's take a minute, let's talk about our stack and our heap. When I created these 2 arrays, I created 2 variables on the stack and 2 arrays on the heap. I created A, which contains a memory address that points to an array on the heap, which contains 3, 2, and 1, and B, which contains a memory address that points to an array which I filled with 3, 2, 1. The thing is, these are 2 different arrays. So these 2 arrays have different memory addresses. And when I use equals equals, this only compares values on the stack. So it's only comparing the memory addresses. It is not looking at the contents, only the memory address. And so because of this, if I want to determine if 2 arrays are equal, I would need to do something like, first, I have to make sure the arrays are the same length. Because if the arrays are not the same length, obviously they're not equal. So if a.length does not equal b.length, then system.out.println false. Something like that. Else, if they are equal length, at that point I would need to loop through each. And I would need to make sure that index 0 equals index 0. Index 1 equals index 1. Index 2 equals index 2. So I would do this with a for loop. For int I equals 0. I less than, since the lengths are equal, it doesn't matter which I use. So let's go with a.length. I could use b.length since they're the same at this point. And from there, if I is not equal to bi, then they are not equal. And actually what I'll do is I'll create my accumulator, Boolean result. I'm going to first say assume they are equal, and if their lengths aren't equal, result equals false. And if I find a counterexample, result equals false. And then simply system.out.println result. This is how I could compare contents. But if I do equals equals, oh, sorry, I keep saying return, which we're going to get into in a second. If I say equals equals, this is not what happens. If I say equals equals, it is asking, are those 2 arrays the exact same memory address? Sorry, ignore that. That is an old scene that I had back when I did some casting, and I need to delete it. Any questions? The same is true for strings. The same is true for strings. String A equals math. String B equals Nat. B plus equals H. System.out.println A equals B. This is false. And you may think, what? But wait, the strings have the same value. But strings, like arrays, are reference objects. And so when I have a string, it's exactly the same as if I have an array. The value on the stack is the memory address. The value on the heap is the contents. So, if I have two strings, these are still not equals equals. Luckily, Java does have a built-in way to quickly check if two strings are equals. The way you check if two strings are equal is as follows. A dot equals B. And that's all you need. This compares the content of the strings. And so I get true. If I comment out this part and it's math to mat, this is false. Any questions about this? So if you need to check if two strings are equal, use dot equals. Never use equals equals for strings. And you will make that mistake at some point this term. I know because I still make mistakes, and I've been using Java for, God, I'm getting old, half my life. So the question is, so the Boolean equals equals checks memory addresses, not content. Only for reference data types. For primitive data types, it checks content. It checks value. Because remember, there is a value here. This has a value. That value is a number. And so when you say equals equals, it's checking, are these numbers equal? Because the memory addresses are numbers. So if you have two ints, the value is stored on the stack. It's not stored on the heap. It just compares the values. So equals equals just compares whatever's on the stack. Primitive data types are stored entirely on the stack. Well, at least local variables. We'll talk about global variables tomorrow and how those are on the heap, but that's a separate thing. We'll get to that later. Primitive data types are on the stack and are compared by value. Reference data types have a variable on the stack that points to a memory address. And that variable on the stack is basically an int. It is a number. And equals equals just compares the numbers on the stack. Are there any questions about that? All right. So now let's take a minute and let's quickly discuss functions. And you'll notice all the functions that I'm going to do are basically already here. There's review for methods, and then there's functions. Functions is much shorter. Review for methods has quite a bit here. Functions in Java are called methods, and there's a reason they are called that, but we're not going to get into that today. We won't get into that really until we talk about objects. But let's just do a quick little example, function examples. And obviously at this point, we expect that you are familiar with writing functions, so this is just a review of how Java functions are written. Let's say I wanted to write a function that takes in two numbers and returns the larger of the two. Write a function that takes in two numbers and returns the larger number. Well, the first thing is in Java, I have to declare And for now, we're just going to always say public static. That will change Thursday. I have to declare my function as public and static. I need to give it a name, something like max. But like everything else in Java, I have to declare what data type this function is. This function, max, takes into, we'll call them integers, takes into integer numbers, and returns the larger of the two. So this is an int function that takes in int a and int b. Unlike Python, you have to declare the data type both of the inputs and of the output. From there, I can do this with a simple if statement. If a is greater than b, return a. Else, return b. And that is how you write a Java function. Instead of def, you use public static. You have to declare the return type of the function and the return and the input types, the data types of the input. You surround your function with brackets just like loops, and you use the return keyword exactly like you would in Python. Now let's talk about how we actually call this function. So we're still going to have a public static void main. This is separate from the function itself. Main tends to go at the bottom. That's a common style practice. Not required. Java, the order of the functions is irrelevant. It never matters what order the functions are in. Public static void main. I can do something like int x equals 3, int y equals 7, system.out.println max x, y. And if I wrote this correctly, prints 7. If I wrote it incorrectly, it might not print 7. But if I wrote it correctly, it prints 7. And it does. What I've just done is actually important. This is a form of testing, and we call this main method testing. And by the way, you don't actually have to define variables here. You could just say max37. That's also fine. This is main method testing, and the idea here is I want to make sure my function works like I think it works. I want to make sure my function works like I think it works. So I call the function with a particular input, and I test it, so 3, 7's the input, to make sure that the output I get is the output I expect. If I say, give me the maximum of 3 and 7, I would expect 7. Are there any questions about this? Now let's say I had a separate function. I wanted to write a function. No, there is no built-in function called max. In Java, there is no built-in function called max. This is calling this function. Here, I'll change this to maximum, and you can see that I have to change this to maximum just to avoid confusion. There is no built-in function max. There is a function called math.max 3, 7. That's a function that exists. But there is no function called max. So I'm testing my own function. Now let's consider another function. This function is not going to return anything. Rather, print if a number is odd or even. This function doesn't return anything. It's just going to print. Printing is not returning. They are different things. In this case, if I'm not returning anything, I still need to declare a data type for my function. And that data type is void. Odd or even. Int x. Void means this function does not return anything. So I can't use return something. Instead, I will do something like if x mod 2 equals 0. This is a way to check if a number is even. System.out.println even. Else system.out.println odd. This function won't have a return type. So I don't need to print the output to test it. I can simply just call odd or even 5 should print odd. And I can test it with an even number, odd or even 6 should print even. That's because the function itself handles the printing. So let's go ahead and test this. And there we go. Are there any questions about how these functions are defined? All right, so now I have a challenge. This is not the daily activity. There is a daily activity, but this one's going to be an activity that I do with you. Within the lecture, it's not graded. Take a minute, though, and talk to each other, jump in the Discord, help each other out, see if you can. Try to write this function. Public static boolean is prime int x. Just to avoid confusion, I'm going to say int a. We'll talk about variable scopes tomorrow. Is prime. This function returns true if the number is prime, false if composite. And I will stipulate that you may assume a is always greater than or equal to 2. You don't need to check it, just assume this is true. If you're not familiar, a prime number is a number like 7, where no number except 1 and itself evenly divides the number. So 7 divided by 1, that works, no decimal place. 7 divided by 7, that works, no decimal place. The number 15 is not prime, because 15 divided by 3 or by 5 gives you a whole number. How can you do this? And I will tell you now this is tricky, and I will post the solution here in class. But I want you to take, say, 5 minutes, jump in Discord, or just try to work on this yourself before I do the solution. And we'll be right back. All right, let's bring it back. Let's see if we can work this out together. So the simplest way to do this is simply to loop from 2 up to, and you don't need to go all the way to the number. You can actually just go up to the square root of the number, up to and including the square root of the number, in order to determine if it's prime. The reason for it being the square root is if the number has a cofactor that's less than the square root, it has one greater. Or if it has a cofactor greater than the square root, it necessarily has one less than the square root. And there's reasons for that. I'm just not going to get into it for the time being. So let's first try this loop. For int I equals 2, I less than or equal to math.square root of a, I plus plus. From there, I'm simply going to see is a evenly divisible by I. So if a mod I equals 0, then what that means, I evenly divides a. If this is the case, if I evenly divides a, this means the number is not prime, and I can simply return false. There's no reason to continue. I found one example, return false. However, if I finish this entire loop, and I have not found any cofactor, then this means the number must be prime, return true. This is how I would do it. Let's go ahead and test this. Make sure I wrote this reasonably correct. System.out.println is prime. 12 is a number that is clearly not prime. So should print false. System.out.println is prime. 127 is prime. So should print true. System.out.println, on the other hand, 169 is not prime because it is 13 squared. Should print true. Is not prime. Should print false. Excuse me. So let's go ahead. We're looking for false, true, false. And we got it. Now, I have another challenge. Public static void every prime to 100. What I want this function to do is print every prime number from 2 to 100. How can I do this? Well, it's actually fairly straightforward. For int I equals 2, I less than 100, I plus plus, I simply need to determine if the number's prime. What's the easiest way for me to determine if a number is prime? Anyone? What would be the easiest way? I could copy and paste the code. Is that the best way to do it? Just copy and paste the code here? Just use the function. Call the function. Right? If is prime I, system.out.println I. Else, we're not printing the number. And so, we run this function, and let's just go ahead and test it. System.out.println every prime to 100. Actually, I don't need to print this function. I just need to call it. And if you look at this, this is indeed every prime number from 1 to 100. So there we go. I'll go ahead and leave this code up for a bit. Are there any questions? Any questions about functions that we've talked about so far? Because we're not getting into yet overloading or pass by reference, which we will get into tomorrow. And we're not getting into global variables yet. So, the public static void main. The function's name is main, the same way that this function's name is prime. It's a void function because it doesn't return anything, like this function. Public static, for now, because we're just telling you to do public static. We'll get into where we don't do public or static. Actually, we'll get to not using static first. But that's a special circumstance. For now, ignore it. The function takes in an input array of arguments. This you won't see, but what you can do when you run a Java function, and I'll just show you an example that I have. So I wrote a simulator for a little fun league that I'm in. Let me pull it up. And this actually uses command line arguments. We're not going to in this class, but let me show you how those get used. So I can do something like, this simulates this little league I'm in. It has different divisions. Let's say I want to simulate division B East. So BE using a 50-50 model 100 times. Or hang on, I got it backwards. 100 simulations using a 50-50 model. Oh, I'm in the wrong folder. That's why. This is just a little program that I wrote. It takes these values, these strings, and it puts them into the program. And that gets populated into this variable called args, which is an array of strings. We're not going to use that in this class, but it's useful. You'll get into why command line arguments are sometimes a valuable tool. The advantage is I can change the parameters of this program. Like I can run a different division with naive assumptions, and it will give me that. And I don't need to change the code. The program just changes the values. So that's a way to get values into a program without actually editing the code. Because how many times have you run a program where they're like, okay, if you want to enter that number, go into our code and change this variable. You don't do that. So command line arguments are a way to do that, and they get passed to main this way. However, typically when you just hit run in Eclipse, args is empty. You won't ever use it. So it's just empty. It's an empty array. It's an array of length 0. All right, the last thing I'm going to talk about today is something called default values. When I create an array, int array x equals new int 5, this array is not empty. The thing about this array is that this creates a space with 5 blocks. Here I have 5 spaces. And this is where the apartment building analogy may start to fail if you think of it this way. Unlike apartment buildings, none of the rooms in this array can be empty. All of them have to have a value. Even though I haven't specified it, all these have a value. System.out.println x arrays dot to string x. And if I run this, you'll notice that all the values are 0. That's because the default value of all primitives is 0 or the equivalent of 0. So if I change x to a double, the equivalent of 0 for the double data type is 0.0. And you'll see that that is what prints. And if I change X to a car, it's actually going to look weird. Because if I run this, it's going to look like nothing prints at all. What's happening here? Well, we need to go and take a look at our ASCII table again. And the ASCII table, the 0 value, is something called null. Null, very specifically, means nothing. To be clear, int s equals that. This is not null. This is a white space, or like if you hit the space bar, that's what you get. Null for a character, hang on, let me change that to car. Null for a car, car n equals null, is written in code as /0. And this is null. And when it prints, nothing prints. Not even white space. So that's the equivalent value of 0 for character. If I change this to Boolean, anyone want to guess what the value or the equivalent value of 0 is for Boolean? You've taken Python, so this should be fairly easy. What is the default value for Boolean? Based on what I've said. False, exactly. It's false. Let's go ahead and run this, and it's false. What about string? What is the default value of string? Anyone want to take a guess? What's the default value of string? Is it maybe an empty string? Okay, empty string. That's a suggestion. It's actually something else. It's not that. It is null. But I want to be very clear. String s equals null. This is not null. This is a string containing the letters N-U-L-L. String n equals null. Notice the word turned orange. That's because it's a reserved word in Java. So as we talked about before, strings are reference data types. And as a result, every value is actually just a memory address. So A points to here. So when I created the two strings that I have, and I'm just going to quickly point them out here, just noting, I'm talking about these two strings, S and N. S is the string containing the word null, N is null. Here's what that actually means. What that actually means that S contains a reference to somewhere on the heap that has a memory address saved for the word null. N is null. What this means is it actually has no address. This doesn't point anywhere. It's like an address that doesn't exist. Null is actually not nothing. And that may sound weird. Null is not nothing. Instead, think of null as nowhere. That is to say that this is an address to something that doesn't exist. And so there is nowhere on the heap where this string is stored. So when I create an array of strings, it takes on the default value of null, which is to say they aren't strings. Null, while it's stored in a string variable, is not a string because it has no connection to a string on the heap. So null values are values that do not point to anything. And only reference data types can be null. Only reference data types can be null. So to that end, this is allowed. A string can be null. Another reference data type is an int array. Int array A equals null. This is allowed. You cannot, however, say int Y equals null. This is not allowed because primitive data types cannot be null. Because primitive data types are not addresses. Remember, null means nowhere. It means an address that doesn't point to anything. Primitive data types are not stored by their address. They're stored by their value. And so as a result, this can't happen. So the default value of any array of reference data types, and we'll call them objects later, the default value is always null, which means nowhere. And we'll talk about the implications of null, especially when we get to objects. But with that, we are out of time, so I'm just going to point you to today's daily activity, this one will be graded, and you're welcome to work on this with each other. We won't always have class time to do the in-class activity, but certainly you are encouraged to jump into Discord. If you need help, there is office hours after class every day of the week, Monday through Friday. We're happy to help there. But the in-class activity today is you are going to download this program Points in a Plane, and you're going to implement this function to meet these requirements. Additionally, you are going to need to write at least 2 main method tests. So that's your homework, or that's your in-class activity for today. It's not overly difficult. Remember, these are not graded on correctness, but they are graded on effort. So if you turn in something immediately after class that's just this file with no modifications, you will not get credit. I also want to note, we only got 34 submissions for the in-class activity today. They are a 15% of your grade, so you do need to submit them. With that, that's all I have for today. I will stick around for about 5 minutes for any questions, but I will not be lecturing on any new material the rest of the day. It's 3:15, so class is over. Are docstrings needed for functions in Java? They are, and we will go over how to comment functions tomorrow. Where are the readings? The readings, so I think I answered this when you asked, or was it you that asked earlier, or maybe it was someone else? The reading schedule will be up immediately as soon as I'm able to finish it. I apologize that it wasn't done yesterday, but there were more urgent matters in terms of the homework and the quiz that I needed to attend to. Are you allowed to share some parts of code for today's activity? You are always allowed to share code for the in-class activity and only the in-class activity. You are explicitly prohibited from sharing code on homeworks, on quizzes, and on exams. However, in-class activities, not only are you allowed, you are encouraged. And that's because the in-class activity is not designed to test your knowledge. It's designed to get you thinking about the topic. The daily activity and the in-class activity are the same, yeah. Sorry, during the semester, we call it in-class activity, and I just haven't gotten my mind through that nomenclature yet. So it is the daily activity. You're very much encouraged to share code for the daily activity, and only the daily activities. What is an edge case? An edge case is something like something that's at a border. So if I were to say to do an absolute value function, There's clearly absolute value function should behave one way if my number is positive and behave a different way if it's negative. 0 is between those two boundaries, so that's an edge case. Sorry, that's me tapping, and that's why I normally have a noise gate, because I have ADD and I tap a lot. Any other questions? It's awkward just sitting here, so I'm going to put on the Lost Odyssey music, and I will break it if any questions come up. Oh, question. What are reference data types again? They are data types. They are data types who on the stack is not stored the value, but rather an address for where the information is found. Primitive data types just store the value on the stack. Sorry. And I'm going to put the is prime code back up, just because I'm sure people are interested in it. And by the way, you can always come back to this. Also, if you don't know this, you can actually do clips on Twitch. There's like a little, like, you know, the Hollywood Shutter thing, the clapper. Like the black and white thing with the lever, and you go clap, action, like whatever. That thing, that symbol, if you click on it, you can clip and you can choose like a small segment of time. So if something ever stands out in lecture and you're like, I want to remember this, absolutely clip it. There's no downside to that. Please don't clip me sneezing or something, because I find that stuff awkward. I don't know. All right. Have a great day, everyone. Take care. Thank you. And I will see you next time, or well, I don't have office hours between now and class tomorrow, but there are TA office hours. So again, always check that schedule tab in Discord. Bye, everyone.